So today we're going to be taking a look at a question from a further Pure 2 paper from MEI in 2006. The question in particular is question 3, part 3, where we are given that the matrix M is 1, minus 2, 2, 2, minus 3, 2, 3, 6, minus 4. And we are also provided with the fact that one of our eigenvalues for this matrix, we'll call it lambda, is minus 1. So what this particular part of the question requires, question 3, part 3, is that we need to find the eigenvector that corresponds to this eigenvalue. Well, of course, there are many ways to do this, but this particular mark scheme actually alludes to a far quicker way than having to solve a set of simultaneous equations. So what we can do is we know that this is an eigenvalue because it's provided, and we know this is our matrix. So we begin by formulating this as M minus lambda I, and where I is our identity matrix. So just to recap, I is 1, 0, 0, 0, 1, 0, 0, 0, 1. So that means that M minus lambda I, where lambda is minus 1, is going to give us 1 minus minus 1, so 2, 2, 3, minus 2, minus 3 minus minus 1, minus 2, 6, and then 2, 2, and minus 4 minus minus 1, so minus 3. So this is, just to recap, M minus lambda I. So at this point, we can actually perform a very interesting trick, which will mean that we can almost instantly get our eigenvector as the question requires. So looking at M minus lambda I, if we draw in two horizontal lines, like so, so we split our matrix essentially into 3 rows. And let's take this row, so the top row, and this row here. And what we're going to do is find the cross product. So what we're going to say is 2, 2, 3. And where that comes from is 2, 2, 3, crossed with minus 2, minus 2, 6. And now we can evaluate this. So we know that our first entry, so a quick method to evaluate the cross product is if we put our finger over the row that we're interested in. So we want the entry for this top row. 2 times 6 is 12, minus minus 6, so we've got 18. Same trick again. So now we get 3 times minus 2 is minus 6, minus 12, minus 18. And then our final entry along the bottom here, 2 times minus 2 is minus 4, minus minus 4, so we get 0. And obviously this can be simplified. And actually, as it turns out, therefore, our eigenvector for our eigenvalue that lambda equals 1 is 1, minus 1, 0. And of course, if we wish to check this, we can take our M. So if this is our sort of checking step, just to make sure this has worked and it's not a lie, put M, minus 2, 2, 2, minus 3, 2, 3, 6, minus 4. So that's just M from there. We're going to multiply it by this and then use the properties of this multiplication just to verify. So remember, when multiplying matrices, we go along the diving board and then down. So we're going to get 1 minus 2 plus 0. So we get minus 1. Here we get minus 2 plus 3, so 1 plus 0. Looking good so far. Finally, 2 minus 2 is 0 plus 0. And as you can see, this is our eigenvector, eigenvalue even, minus 1, multiplied by our eigenvector. as we just have minus 1, 1, 0, which means that this is indeed the correct eigenvector, and it's a far quicker way, so long as we're familiar with this cross product, to evaluate the eigenvector. Comment below the remaining eigenvalues for this matrix and let me know if you can use the same method to calculate their corresponding eigenvectors. Thank you very much for watching, and I'll see you in the next video.